In this video, we have to find all positive integers n such that 3 power 2n plus 3n square plus 7 is a perfect square. So we have 3 power 2n plus 3n square plus 7 and it is a perfect square. So suppose it is equal to k square and it is 3n square plus 7 is equal to k square minus 3 power 2n and it is 3n square plus 7 is equal to k square minus 3 power 2n is 3 power n square and it is 3n square plus 7 is equal to a square minus b square is equal to a plus b times a minus b. So we can get k plus 3 power n times k minus 3 power n. And in the right hand side, we have product of two integers. But in left hand side, 3n square plus 7 is not a constant. If it was a constant, for example 4, then we can write it as 1 times 4, 2 times 2 and 4 times 1. But 3n square plus 7 is not a constant, it is a variable. So we cannot write it as a product of two integers. So this method will not work here. So we need to think it in a different way. So we have 3 power 2n plus 3n square plus 7 and clearly it is greater than 3 power n square. Here 3 power 2n plus 3n square plus 7 must be greater than 3 power 2n because n is positive integer and 3 power 2n can be written as 3 power n square. So it must be greater than 3 power n square. And the number next to 3 power n is 3 power n plus 1. So suppose for some n, 3 power 2n plus 3n square plus 7 is less than 3 power n plus 1 square. So it is 3 power 2n plus 3n square plus 7 is less than 3 power n square is 3 power 2n plus 2 times 3 power n plus 1 and 3 power 2n will get cancelled and we get 3n square plus 7 minus 1 is 6 is less than 2 times 3 power n. And if we draw the graph here, this will be the graph of 2 times 3 power n and at n is equal to 0 it will be 2 and at n is equal to 0 3n square plus 6 is 6. So it is 6 at n is equal to 0 and the graph will be like this. It is the graph of 3n square plus 6 and at n is equal to 1 this is 9 and this is 6 and at n is equal to 2 this is 18 and this is also 18. Here at n is equal to 2 3n square plus 6 is 18 and 2 times 3 power n is also 18. That means this point is n is equal to 2 and the exponential function grow much faster than polynomial. That means this gap will continuously increase. So these two graphs will never intersect again after n is equal to 2. So for n greater than 2, 3n square plus 6 is less than 2 times 3 power n. So 3 power 2n plus 3n square plus 7 is less than 3 power n plus 1 square for n greater than 2. And 3 power n and 3 power n plus 1 are consecutive numbers, so this cannot be perfect square. And now we have two positive integers left, n is equal to 1 and n is equal to 2. So for n is equal to 1, 3 power 2n will be 2 plus 3 times 1 square is 1 plus 7, and it is 9 plus 3 plus 7 is 19. That is not a perfect square. And for n is equal to 2, 3 power 2 into 2 is 4 plus 3 into 2 square is 4 plus 7, and 3 power 4 is 81 plus 3 into 4 is 12 plus 7, and it is 100. That is perfect square. So n is equal to 2 is the only solution of this equation.